Cauchy integral test. Let series An is equal to series Fn is a positive term series where Fn satisfies the following conditions for x greater than or equal to 1. First condition is Fn greater than 0. Second condition is Fn is continuous. And third condition is Fn is decreasing as n tends to infinity. Then the series and the integral of the function either both converge or both diverge. Now this convergence and divergence depends on the value of this integral. Okay. Now the value of this integral is suppose L. If L is finite, then this integral and this series both converges. Okay. If this L is infinity, then this series and this integral value both diverge. Okay. So convergence and divergence of this series is depend on the value of L. If L is finite, then the series is convergent, and if L is infinity, the series is divergent. Ratio test. Let series An be a given series. If L equal to limit n tends to infinity mod of An plus 1 upon An. Here An is what? Nth number of term of the series, and An plus 1 is n plus 1th number of term of the series. Here ratio of successive terms are taken. Okay, so that's why this is known as ratio test. If L is less than 1, then the series is convergent. If L greater than 1, then the series is divergent. And if L equal to 1, then the test is inconclusive. Now test is inconclusive means we cannot say about the convergent and divergent of the series from this test. Okay. So if L equal to 1, we cannot find any conclusion about the series. Root test. For the series An, let L equal to limit n tends to infinity nth root of mod An. Then if L is less than 1, then the series is convergent. L greater than 1, the series is divergent, and for L equal to 1, the test is inconclusive. Now the question is that when to use ratio test and root test. If in a series terms contain factorial, okay, and suppose given n factorial, so factorial is there. Okay, so if term contain factorial or powers of n, for example n raised to n, okay, so in this case apply ratio test. If power of n is given, then apply root test. So if power of n is given, then you can either use ratio test or root test. But if factorial is given, only ratio test is applicable. Okay, so for factorial only use ratio test. Alternating series. A series in which the terms occur alternatively positive and negative is called an alternating series. General form of alternating series is summation n is 1 to infinity minus 1 raised to n minus 1 an, or n is 1 to infinity minus 1 raised to n an, where an greater than 0. So this is the general form of alternating series. Now to check the convergence of this series, we can apply Leibniz test. So first of all we will discuss what is the Leibniz test. The alternating series converges if the following conditions are satisfied. First condition is mod an plus 1 is less than or equal to an for sufficiently large n. So what does it mean? From the alternating series, first find an. Okay, then take the absolute value of an. Also find an plus 1. So how to find an plus 1? In an term, n is replaced by n plus 1. So find an plus 1. Take its absolute value. And here observe, what is the relation between mod an and an plus 1? If mod an plus 1 is less than or equal to mod an for sufficiently large n, okay, then this condition is satisfied. Means here we have to check each and every term is less than or equal to the previous term. Second, take limit n tends to infinity mod an and evaluate it. If this value is 0, then the condition is satisfied. So in Leibniz test, if these two conditions are satisfied, then we conclude that the alternating series converges. If any one condition is not satisfied or both the conditions are not satisfied, then what we conclude? The alternating series diverges. Okay. Next definition, absolute convergence of a series. A series an is said to be absolutely convergent if series of absolute term is convergent. Okay, what to do? Series an is given. Power series, a series of the form summation n is 0 to infinity an x minus c raised to n. Now put n equal to 0, so a0 x minus c raised to 0, we get a0, plus put n equal to 1, so a1 x minus c raised to 1, plus put n equal to 2, a2 x minus c raised to square, and so on. Okay, so this is the general form of power series, where an are constant, c is the center of the series, and x varies around c. Now, what is c? C is the center, okay? And what is x? X varies around c. Suppose x vary in very nearer interval of c. Okay, so this distance is what? This distance is suppose r. Okay, so this is c plus r and this is c minus r. So x lie in the interval c minus r to c plus r. This is the region in which x lie. Okay, so this is known as what? Interval of convergence. Ultimately what we want? We are interested to check whether this series is convergent or not. And if the series is convergent, then in which interval the series is convergent. Okay, so this is the interval in which the series is convergent. And this is the distance r from c. Okay, this is the distance r from c is known as radius of convergence. So what is the r? R is radius of convergence. So now let's discuss the definition. A positive number r is called the radius of convergence of the power series an x minus c raised to n if the series converges for mod x minus c less than r. Okay. Now mod x minus c less than r means mod x minus c less than r. So what we can write? Minus r less than x minus c less than r. Okay. Now to remove c, add c on both the side. So what we get? Here c minus r less than x less than C plus R. Okay. So what is the range of X? Range of X is C minus R to C plus R. That we discuss here. The range of X is what? C minus R to C plus R. Okay. So mod X minus C less than R is what? This is the condition for convergence. Okay. If the series converges for mod X minus C less than R and diverges for mod X minus C greater than R, means in outside region, this is the region. In this region, the series is diverges. Okay. So R is the radius of convergence. Means we are interested to find the distance R from C. Okay. So this distance is nothing but distance capital R. So this is known as radius of convergence, and this interval is known as interval of convergence. मतलब कि हमारी जो सीरीज है वो ये इंटरवल में क्या है, हर एक पॉइंट पे क्या है, वो सीरीज कन्वर्जेंट है, और आउटसाइड इंटरवल क्या है, सीरीज डाइवर्जेंट है. ओके. नाउ इंटरवल ऑफ कन्वर्जेंस. द इंटरवल कंसिस्टिंग ऑफ ऑल वैल्यूज ऑफ एक्स फॉर विच द पावर सीरीज कन्वर्जेस इज कॉल्ड द इंटरवल ऑफ कन्वर्जेंस. मतलब कि ये इंटरवल के हर एक पॉइंट पे सीरीज क्या है, कन्वर्जेंट है. इट इज जनरली रिटन एज इन ओपन इंटरवल C minus R to C plus R. Okay. Including or excluding endpoints depending on converges at the endpoints. मतलब कि पहले हमें क्या करना है, find the interval of convergence, और उसके बाद हमें क्या करना है, एंड पॉइंट पे भी हमें क्या करना है कि सीरीज कन्वर्जेंट है या नहीं, वो हमें चेक करना है. ओके. सो ऑन दैट बेस वी कैन राइट द इंटरवल if the series converges only at interior point, then this is the interval of convergence. Second, check at the end point. If series converges at this point, okay, we have to find convergent at this point, then it's required to include the point. Okay, तो हमने यहाँ पे वो point include किया है. So that's why this is the closed interval, close to open. Next is C minus R to C plus R, closed interval. मतलब कि ये पॉइंट पे सीरीज कन्वर्जेंट नहीं है, बट एट दिस पॉइंट द सीरीज इज कन्वर्जेंट. ओके. सो दैट्स वाई एक्सक्लूड दिस पॉइंट and include this point. And next, at both the end point series is convergent. Okay. So we can write in this way. So what does it mean? The series is convergent at end point as well as all the interior points. So we have possibility of having these 4 type of interval of convergence. The next is how to find radius of convergence and interval of convergence for power series. For this purpose, we use ratio test. So test of convergence of power series using ratio test. Consider the power series n is 0 to infinity an x minus c raised to n. Okay. Now apply ratio test. So for ratio test, what we need? As per the definition, L is equal to limit n tends to infinity so this is the definition of ratio test. So take limit n tends to infinity an plus 1 upon an. So now here n is replaced by n plus 1. So we get an plus 1 x minus c raised to n plus 1 upon an. So an is x minus c raised to n. Now simplify this. So here x minus c raised to n plus 1, x minus c raised to n. So n is cancel out. Okay, so that's why what we get? Only x minus c. Now separate this. So mod an plus 1 upon an into mod x minus c. Here this term and this n term is cancelled out. Okay. Now next is, for this take the assumption. Now this term is free from n. Say yes or no. Here x and c is the constant number. Okay. So this term is free from n. Okay. So that's why we keep as it is, and for this we take the assumption. Suppose the limit value of this is small l. Okay. Now what is the condition for ratio test? For ratio test, if L is what? Less than 1, then series is what? Convergent. Okay. If L is less than 1, then the series is convergent. So that's why here, what is my L? L is equal to, now put this value here. So we get L into x minus c. This is my capital L. Okay. If this value is less than 1, then the given series is what? Convergent series. Okay, as per the ratio test. So that's why write this condition. For convergence, capital L is less than 1. But what is the capital L? Capital L is small l into x minus c. Put from here. So L x minus c less than 1. Now shift L here. So we get 1 upon L form. So now hence the radius of convergence is what? This one. Okay. So capital R. This is capital R is equal to 1 upon L. So 1 upon L is what? Radius of convergence. Because here we have the form mod of x minus c less than capital R. And as we discussed earlier, mod of x minus c less than R. Okay. So this is the radius of convergence. So that's why here what is my R? R is 1 upon L. An interval of convergence is obtained from mod of x minus c less than R after checking convergence at the endpoints. And this point we already discussed earlier. Okay, how to check the endpoints? How to check the convergence at the endpoints. Okay. So to find the convergence of the power series, we use the ratio test.